The Theory of Political Economy by William Stanley Jevons. Chapter 4 Theory of Exchange. Part 15 Complex Cases of the Theory. We have hitherto considered the theory of exchange as applying only to trading bodies possessing and dealing in two commodities. Exactly the same principles hold true, however numerous and complicated may be the conditions. The main point to be remembered in tracing out the results of the theory is that the same pair of commodities in the same market can have only one ratio of exchange, which must therefore prevail between each body and each other. The cost of conveyance being considered as nil, the equations become rapidly more numerous as additional bodies or commodities are considered, but we may exhibit them as they apply to the case of three trading bodies and three commodities. Thus suppose that A possesses the stock of A of cotton, and gives x1 of it to B, x2 to C. B possesses the stock of B of silk, and gives y1 to A, y2 to C. C possesses the stock C of wool, and gives z1 to A, and z2 to B. We have here altogether six unknown quantities, x1, x2, y1, y2, z1, z2. But we have also sufficient means of determining them. They are exchanged as follows: A gives x1 for y1, and x2 for z1. B gives y1 for x1 and y2 for z2, and C gives z1 for x2 and z2 for y2. These may be treated as independent exchanges, and each body must be satisfied in regard to each of its exchanges, and we must therefore take into account the functions of utility or the final degrees of utility of each commodity in respect of each body. Let us express these functions as follows: phi1, psi1, he1 are the respective functions of utility for A. Phi2, psi2, he2 are the respective functions for utility for B, and phi3, psi3, he3 are the respective functions of utility for C. Now A, after the exchange, will hold A minus x1 minus x2 of cotton and y1 of silk, and B will hold x1 of cotton and B minus y1 minus y2 for silk. Their ratio of exchange y1 for x1 will therefore be governed by the following pair of equations: phi1 A minus x1 minus x2 over psi1 y1 equals y1 over x1 equals phi2 x1 over psi2 b minus y1 minus y2. The exchange of A with C will be similarly determined by the ratio of the degrees of utility of wool and cotton on each side subsequent to the exchange. Hence we have phi1 A minus x1 minus x2 over he1 z1 equals z1 over x2 equals phi3 x2 over he3 C minus z1 minus z2. There will also be an interchange between B and C, which will be independently regulated on similar principles, so that we have another pair of equations to complete the conditions, namely psi2 B minus y1 minus y2 over he2 z2 equals z2 over y2 equals psi3 y2 over he3 z minus z1 minus z2. We might proceed in the same way to lay down the conditions of exchange between more numerous bodies, but the principles would be exactly the same. For every quantity of commodity which is given in exchange, something must be received, and if portions of the same kind of commodity be received from several distinct parties, then we may conceive the quantity which is given for that commodity to be broken up into as many distinct portions. The exchanges in the most complicated case may thus always be decomposed into simple exchanges, and every exchange will give rise to two equations sufficient to determine the quantities involved. The same can also be done when there are two or more commodities in the possession of each trading body.